have two words, traducere automatizată, traducere automata, very close as a matter of fact. In English, luckily, the words are distinct. But anyway, the difference between them is essential. Automized translation, TA, is different from high-quality automatic translation, which is a fundamental objective of artificial intelligence. But anyway, TA, traducere automatizată, which would be automized translation, is essential. Briefly, TA, automized translation, involves a processing flow in which the machine will translate a document and then, if necessary or required, there will be the human intervention or correction factor. Actually, we are dealing with a new concept, 1.5, 2 years old. And it is meant to improve quality. The more correct MT is, the lower the effort of the human translators. But automatic translation is different from CAT translation. I'm aware most of you are familiar with CAT tools. In CAT tools, the process is interactive. Human translators receive some suggestions as input. They can be rejected or changed according to the translator's views. In automated translation, first there is MT, machine translation, and then human interference. Translation as such is complicated. There is no formula to reflect it. And there are several arguments we can put forward to substantiate my point of view. I won't insist on them. But as for the history of automated translation, which is one of the oldest field of research in IT, there have been several attempts to solve this problem with several approaches. At the beginning, the approaches were based on formal grammar, norms that were applied to the languages, grammar. And grammar sometimes involved 10-15 simple rules in the 50s, or even tens of thousands of rules in the 80s. For instance, English grammar was thus developed, the system to reflect English grammar was developed by several experts for a decade. But results were disappointing in terms of accuracy, mainly. The results did not reflect the amount of effort invested. The transfer from the source language to the target language did not reflect the effort either. So we needed a new paradigm. This major change occurred in late 80s, early 90s. with researchers from the IBM lab from New York Heights. And this new paradigm meant automatic learning, another field of artificial intelligence, a field, a high-tech field in the 80s. What is automatic learning, automated learning? It is a way in which a system can learn, solve problems by analyzing similar problems already solved. From the solution as such, the system is able to resolve similar new problems. This new view is very close to the idea of automatic translation. This way, learning becomes core to the solution. However, any automated solution can only be an approximation, and any approximation can only be imperfect. And it requires constant improvement. And this is precisely what translation experts are doing now. Automatic translation focuses on data. Data is the very essence of building any statistical automatic translation tools. But what kind of data? There are several types of data, but two of them emerge as essential, and you can see them in red there. First, parallel text or bilingual text, bi-text as we call them. They represent mutual translation of the same contents. The language from which we translate is the source language, and the language in which we translate is called target language. Well, the second type of fundamental data is monolingual data in the target language. But of course, the quality of the translation result obtained from what the system learns from the data is much higher, on condition that besides this unstructured data, the system feeds on structured data such as linguistic knowledge, as it is reflected in dictionaries, monolingual or bilingual terminology, ontologies, list of abbreviations, and so on. And another important observation under the last bullet, statistical machine translation yields good results only in the training field. In other words, suppose we train a system to do legal translation. Only there we get good results when it comes to the translation of new text. The new text should be legal texts. If we ask the same system to translate literary text, the result would be ludicrous or hilarious. Or if, suppose, we want the system to medical translation, the result will be bad. As I said, any statistical machine translation relies on learning. What can we learn from data? A first layer of learning is known by the experts as alignment at the level of the sentence or sentence alignment. Many of you are professionals in the field of translation, and you know very well that the sequence of sentences may change from the source language to the target language. And this is just one example. A paragraph where you can see the two sentences reflected. This is a professional translation, what you see at the bottom of the page, but the result was one sentence only. This is a process that can be automated, and the systems that do that reach a degree of precision of a rate of precision of close to 100%, with no dictionary whatsoever, but based on statistical considerations plus learning. Having shown this kind of correspondence, the next step is to refine more the alignment between the two texts and go deeper to the level of words. And of course, this equivalence is shown here: bright senin, daisy, April, aprilia, so you can see the matching words. This operation too can be automated. They are now highly performing systems. This is a capture, screen capture. While using such a system, where you can see that we don't have a one-to-one match between the languages. Sometimes in some of the sequences or some of the strings of words, we cannot translate a word by another word, but rather we can translate words by phrases. Once the system learns from the two types of fundamental data already mentioned, parallel texts and monolingual texts, some formal representation of the process is achieved. You can see them here. This is the fundamental equation of machine translation. Through translation models and language models. The translation model is the result of what the system learns from bilingual texts. The translation model is a collection of associations between words from the source language and words from the target language, or phrases accompanied by numerical information,
de informație numerică, care
which is called
de regulă este referită în cadrul
translation probability rate,
mai exact ar fi
an estimation of the probability translation rate. The language model includes information about structures, sequences in the target language, seen as are deemed valid in the training data.
datele de antrenare.
Well,
Și pentru a
let me
vă
show you how this
încerca să vă
software
sugerez
works.
cum funcționează aceste programe,
I suppose
să considerăm
we don't have too many experts in Chinese in the room, so this is a menu in Chinese.
avem o pagină din meniu în care aveți
And the translation of the same menu in English. Let's suppose that we would like to translate egg drop. We can see this combination is there several times, so we expect the translation to be on the corresponding lines. So we would like to identify the ideogram that, or the symbol that corresponds to egg drop. Is this one? Is it this one? No, because it's only on line 64.
We suppose, therefore, that it has nothing to do with egg drop and we leave it out. Could this be the ideogram? No, because obviously it's too present in too many places. So we suppose that this ideogram means soup, and we have just one candidate on line 64, which we find on the other lines as well. So it is highly plausible that the correspondence is the correct one. Following a similar approach, we find wonton, and I'll continue with another example, Romanian French. Let's say we have a corpus of French, a corpus of Romanian. We put the sentences line by line, and they come in pairs. We've also aligned the words. And you see there are different colors used as well. The colors suggest equivalences in translation. Out of this nano corpus, we can construct a dictionary, a translation dictionary, a rudimentary tool or a tool at an emerging or incipient tool. I is translated with J apostrophe or J-E, je. The first translation appears twice here, while the second translation is present only once. Let us suppose that following the learning process, we would like to translate the sentence, I speak or I talk to the girl. All the words exist in our corpus. We know the translation for each of them, but the sentence as such was not constructed previously. So one solution is very simple and bad, is therefore to choose the most frequent equivalent of the translation. If we adopt this strategy, what you see is horrible, and so beside the correct interpretation, translation. And here comes the model.
De fapt, eu am
I've just given you the example of selecting one of the 8 possible solutions. So how do we come to select the best possible solution? And here we have the language model. The language model offers the measure or the measuring unit for a selection of the best.
De pildă, în perechile pe care le-am ilustrat,
In the first version, we have a correct selection. You see, these are examples or samples of correct language. The second version, which is crossed out, statistically, this second version is highly improbable. So it is discouraged. I'm not sure everybody can read this line at the bottom of the page. But the first solution is made of fragments of high score. In other words, it is far more plausible from the perspective of the learning system than the second version. Although here I have represented, with the help of these numbers, the frequency of presence of each and every word. You see that practically most words in the bad solution or uninspired solution have higher frequencies. They are present more times. But the language model corrects this. Anyway, what I offered you here was a highly simplified model. A model of translation is a group of 5 or 6 models. I just wanted to suggest how important this idea is. And now, what you see here on the screen is known under the name of simple statistical translation or translation based on sequences of words developed by the IBM specialists. It's not necessarily better. Everything started the years mid-2000. It is the standard technology adopted by all the companies that provide online translation, Google, Microsoft, Baidu, Asia Online, and so on. And of the systems of translation based on sequences of words, the most widespread is Moses. This is the good one. It is an open system. It was developed following projects financed by the European Commission, and it is the system, in other words, it's the platform of programs and learning that leads to developed specialized translation systems in the DG translation. Moses Core is the cornerstone of MT at EC. I was talking to you about the sources of structured linguistics. Of course, you won't see too much on this screen. I just wanted to impress you, says the speaker. There is a multilingual ontology known as under the name of WordNet. It is the result of research carried out throughout the world. There are over 50 such dictionaries. And here what I wanted to represent are 7 semantic dictionaries that are aligned with meaning in mind. And if you download this presentation and you are curious to see these dictionaries in more detail, you will notice that there is here an illustration in 7 languages of meaning number 1 of a word in English. The word is animal. In conclusion, I would like to convey to you the message that the reuse of existing data is the best means of improving the quality of automatic translation, because there are existing data. You can reuse these data, and this reuse is the best way to improve the automatic translation. Don't underestimate the value of the linguistic resources you already have available or which you will create. And if you haven't done this, please think ahead of a plan of management of resources. ELRC, this unprecedented project of the European Commission needs our involvement in order to do for Romanian to develop a CAF at 80 which will be successful. And I have the hope, I'd like to express my hope, not necessarily my persuasion, but my high hope that we will manage to get the adequate necessary data for our project. Thank you.